Hello again, this is section 12.5, Proving Triangles Congruent by SSS. So today we're going to learn two new triangle congruency rules. We have SSS and we have something called HL, which stands for hypotenuse-leg, and we're going to see how each of these are applied. So we'll start with the most logical one, which is side, 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 SSS. And this is the statement that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So if you take a look at the diagram, AB is congruent to DE, and then if BC is congruent to EF and AC is congruent to DF, then triangles ABC and DEF are going to be congruent to each other. Example 1a, you're given KL and NL congruent, KM and NM are congruent. We are trying to prove that triangles KLM and NLM are congruent. So far we've looked at SAS. Now we're going to look at SSS. So you don't have to look at the angles. All you're looking at are three congruent pairs of sides. So statement 1, KL is congruent to NL, and that is given. Statement 2, Km is congruent to Nm, and that is also a given statement. Now the third side, and you'll see this a lot, and anytime you're looking for a congruent side, is the reflexive property. You see that LM is congruent to itself. LM is a side that's part of both triangles, KLM and NLM, and LM is congruent to itself by the reflexive property of congruence. So now notice you have three pairs of congruent corresponding sides, which leads to statement 4. KLM is congruent to triangle NLM by SSS. So again, for SSS, you just need to show all three pairs of corresponding sides are congruent. Don't have to worry about the angles. Now let's look at example 1b. Given segment HF is congruent to segment HJ. We have FG congruent to JK. And we're also told that H is the midpoint of segment GK. Prove that triangles FGH and JKH are congruent. Remember, when you're proving triangles congruent, the letters order matters. So in this case, they tell you what the order is so you can easily match things up. Okay, statement 1, HF congruent to HJ, and that is given. Statement 2, FG is congruent to JK, and that is also given. So now you have two of the congruent corresponding sides. Where's the third one? Statement 3, you're given that H is the midpoint of segment GK. So what you're going to do with this midpoint is then show that the third pair of sides are also congruent. And here it is. Segment GH is congruent to segment HK, and that is by the definition of a midpoint. What the midpoint of a segment says, that a midpoint bisects a segment into two congruent segments. In this case, GK's midpoint of H bisects segment GK into two congruent segments, GH and HK. So now you have SSS, so triangle FGH is congruent to triangle JKH by SSS. So SSS is the most straightforward of the congruency rules. You don't deal with angles. And when you look at that side, you're going to see a lot of the reflexive property. You'll see something like midpoints, so you'll have the definition of a midpoint. You'll have segment bisectors. So all these things apply to get you that last pair of congruent sides. Now, some of you looked at the letters SSS and SAS, and you're probably wondering, what about ASS? That's funny. Well, turns out SSS and SAS are valid methods. SSA doesn't work. So here you have triangle ABC and DEF. You will notice that angle A is congruent to angle D, EF is congruent to BC, and DE is congruent to AB, but the triangles are not congruent. So you can see that AC and DF are different lengths because what this side over here does, it's like a hinge. So this is like a door, and it can open all sorts of directions. So you can get something very wide or something even narrower. So if you imagine again what this looks like, side BC looks like a door that can open further or closer to angle A. And so because of that effect, you cannot conclude that the two triangles are congruent. So SSA does not work. Don't use it. All right, next we have right triangles. As a reminder, right triangles, the sides adjacent to the right angle are called the legs, and those are the two shorter sides. The side opposite the right angle is the longest side. It's called the hypotenuse. So that's going to lead us into our next congruency rule. So the hypotenuse-leg theorem, or HL for short, says you need three things. You need a right triangle, you need congruent hypotenuses, and you need a congruent leg. So again, you need three things. You need a pair of right triangles, you need congruent hypotenuses, and one of the legs in each triangle, the corresponding legs, have to be congruent. So three things, even though it's just HL where it looks like two, that third thing is a right triangle. So in this diagram, AB is congruent to DE, so that's the pair of congruent hypotenuses. AC is congruent to DF, those are the pair of corresponding congruent legs. And you're given that angle A and angle F are both right angles, which means each triangle is a right triangle, then triangles ABC and triangle DEF are congruent. So when you're using HL and Proust, you'll have to use the following logic. HL requires that you show that both triangles are right triangles. So that's one of the three parts. So if you have perpendicular segments, here's the path you will have to write. Perpendicular segments mean right angles by the definition of perpendicular lines. Once you have right angles, you can conclude that right triangles are triangles with right angles by the definition of right triangles. A right triangle is a triangle with one right angle. So this is the path you need to follow in your proofs. If you're given segments are perpendicular, that means they form right angles. If a triangle has a right angle, then it's a right triangle. That is what you need to state in your proof for HL. 3a, given WY is congruent to XZ, WZ is perpendicular to ZY, and XY is perpendicular to ZY, prove that triangles WYZ and XZY are congruent. So what I basically did is take the triangle and split it into two triangles by breaking them up and separating them and reorganizing the letters so they match up. So let's do this. Statement 1. WY is congruent to XZ. Those are the hypotenuses. So that is a given statement. So you have the hypotenuse part of the hypotenuse leg. Second, we'll do both of these at the same time. WZ is perpendicular to ZY. XY is perpendicular to ZY. And that is what was given to you. Notice you are not given that the triangles are right angles or right triangles. You are given that segments are perpendicular. Which means, statement 3, angles Z and Y are right angles. That is the definition of perpendicular lines. So again, perpendicular lines state that the two lines, if perpendicular, form right angles. Thus, angles Z and Y are right angles. Statement 4, triangles WYZ and XZY are right triangles. And that is by the definition of a right triangle. If a triangle has right angles, it is thus a right triangle. So this is what you need to show for HL. You need to show that both triangles are right triangles. Again, notice the progression. Perpendicular lines means right angles, which means right triangles. Statement 5, ZY is congruent to ZY. And that is the reflexive property of congruent. So we have the right triangle, we have the hypotenuse congruent, and we have the legs congruent. Which leads to statement 6. Triangles WYZ and XZY are congruent by HL. So again with HL, pair of congruent hypotenuses, one pair of congruent legs, and a right triangle. Finally, example 3b, you're given segment PQ and RS are congruent. You're also given that angles Q and S are right angles. We're going to prove that triangles PQR and RSP are congruent. So statement 1, you're given PQ is congruent to RS. So that is the given statement. So legs are congruent. Now we're going to look for hypotenuse and right triangle. 2, angles Q and S are right angles. And that is also a given statement. Statement 3, because Q and S are right angles, that means triangles PQR and RSP are right triangles by the definition of right triangle. So again, if a triangle has a right angle, it is by definition of right triangle. Statement 4, PR is congruent to PR. That is the reflexive property of congruence. So you have a pair of congruent hypotenuses. You have one pair of congruent legs, and you have right triangles. So finally, statement 5, triangles PQR and RSP are congruent by the HL rule, hypotenuse-leg. So that's the hypotenuse-leg. Again, you need a pair of congruent legs, a pair of congruent hypotenuses, and that both triangles are right triangles. Again, those do not have to be in that order. They just have to all be included within the proof. That's it for section 12.5.